Now everything's working. We got a audio working. We've got it is recording and we are streaming. So now we can get started with this. Like I said, over here on the left side, we can see that I have some cribbage board ideas that I found. I just went browsing on the internet to see some cribbage boards that other people have made, and we're going to make some cribbage boards, or a cribbage board. The goal of this is a cribbage board using the Vectric software, and we are going to have a removable piece in the center with storage for a deck of cards, or maybe two decks of cards depending on the size that we choose, as well as the cribbage pegs. So we'll go ahead and open up a fresh copy of the Vectric software, and we'll go ahead and create a new file. For this, we're going to set a size of 11.5 square and 0.75 thick. The reason I'm choosing these dimensions is that's roughly the size of a piece of lumber that you would get, if you go to the big box store and you want to buy some 1x12 oak to build a board out of. This is the size you'll get, and it's approximately 1 board foot of S4S lumber, so it should be very easy to help calculate your material costs and get going with that. Now, we are going to make multiple files tonight because not only are we going to have the board itself, but we're also going to make the removable center cover piece. So we'll go material surface and XY datum in the center of the board. And I like going to modeling resolution very high. So go ahead and create our project. Now, where I see this going, and I've made several of these cribbage boards in the past, is we're going to have a rope border using some of our provided clip art in the program. Along the outside, we'll have our 3-track. I like a 3-track cribbage board personally because you can play 2 people, you can play 3 people, or you can play teams. Very rarely do you see just 4 individual people playing, so a 4-track cribbage board is kind of unnecessary. Dustin, thank you for the comment. Make me something pretty. We will do our best to make you something beautiful tonight. So we'll go ahead and get started, and we're going to start with our clip art. So if we go to clip art, and we want to drop down, now all of this is the preloaded clip art that comes with Vectric software. So when you go to the V&Co website, you can download all these with the install files once you've logged in. There's no additional charge once you have the license for the software. What we're going to do is we are going to go to borders, and we're going to use this rope border. Now the first thing we're going to do is we're going to use the A style. And whether you purchase these 3D models from Vectric directly or any of the third-party companies, guys that are creating these 3D objects, there's an A style, a B style, and a C style. The A style stands alone. The B style is a smooth recess or dish in, and the C style is a chip carved look. Personally, I only use the A's and B's. The C's kind of look fake and forced to me, so I don't use those. But for this, what we're going to do is we're going to throw this object into the middle. Now going back to the drawing tab, first thing we're going to do is we're going to align this to the center of the workpiece, and then using our set selected object size, we're going to change this to a nice 11 inches. Our link XY is checked, and there we go. We'll close out of that and go over to our modeling tab, having clicked on the model, and we want to click this third button here, which is create vector boundary around selected components. The reason that we're going to do that is it creates a vector both on the inside and outside of this 3D model that we're using. For you guys that are just now tuning in, I see we have about 15 or 16 people viewing. Tonight we're viewing or designing a cribbage board based on the ideas found on the internet. These are not cribbage boards that I built. These are just being used as inspiration, and we're going along and just building this pretty organically as we go. And if you have questions or comments, you need me to cover something again, please go ahead and field a comment. If you're getting something good out of this, I'd love to hear about it. So now we've created our vectors for the inside and outside of our 3D shape. The next thing we need to do is we're going to work on this one from the outside in. Now, the next thing, I keep saying the next thing, is we need to make a circle that is just inside this rope boundary. We're going to grab our draw circle tool, and we're going to just start with 10 inches. And since our XY datum is at the center point or middle of the material, thanks, Lisa. Go play on my own computer. I could do this on my laptop. However, I just don't have 3 monitors, and that makes this one pretty sweet. So we're going to go with 10 inches, and we see that that's a little bit too small. So let's go with 9.25 and see where that puts us. That's not a bad shape or a bad size, and since we have this other vector here, we want to make sure we delete the circle and not the vector from the rope boundary. And there I just hit F on the keyboard to fit that back to size. Now we're going to just drag this out, make it a little bit bigger. The absolute size of this really doesn't matter, but we'll set this back to the material. So what this is doing is giving us a visual reference of how far out from the inside of that rope border, how close we're going to have our nearest peg hole. And we don't want to go outside that. You want to leave some room. So what we're going to do now is we're going to offset this. And when we offset this, it gives us where we're going to align our center peg hole. Like I said, we're going to build a 3-track racetrack or 3-row racetrack on this cribbage board. And to give us a good idea of how far we need to offset this, we need to build our peg holes first. So again, we'll use this draw circle tool, and we know that our cribbage peg hole needs to be 1/8 of an inch, so 0.125 inches. And we'll create that. That goes straight in the middle. Select this vector, and what we're going to do is use our array copy tool again. Last night we talked about how to use the array copy tool, and we're going to use that again. Now we have 2 options on this. We can make it vertical or horizontal, and we'll actually discuss each of those uses for this. So on this, we're going to make 3 rows, 1 column, and we want our offset to be set. Now that we have rows go across the Y, so we need to have an X offset on this. We want a gap of 0.125 inches as well, and what you can see is that really put those 3 right next to each other because it's going from center to edge. So we'll hit Control Z and go to 0.25. Nope, I don't know what I'm missing something. 3 rows, 1, 2, 3. Y offset needs to be 0.125. Sorry about that. Gap, copy, there we go. And I didn't select group copies here, and we'll just fix ourselves on that by making a set of 3 right there. Josh, I will probably say vector several thousand times during this because it's an easy word to say at this point. I don't have any other excuses for you on that one. All right, we're going to use our tool to copy along vectors. There's another one for you, Josh. Now, we're going to copy the object, and we're going to specify the number of copies. For this, we need to make 151 copies. And we'll go ahead and see what this does. That's what it looks like. This is the reason that we need to offset the pink selected vector around here. Josh says he's going to drink every time I say vector. This is going to end very, very poorly, even if he's drinking water tonight. We know that these are 1/8 of an inch. There's an 1/8 of an inch gap. So that's a total of, from center of this circle to the center of this circle is a total of 1/4 of an inch. So if we want to move the inner circle in 1/4 of an inch, that's what we need to offset. And we'll go ahead and hit Control Z to see what this looks like. Closing this, we'll go to our offset, and we're going to select offset, and we'll go inwards 1/4 of an inch. Selecting our 3 peg holes, and remember, it always goes, we're going to go this to that. We're going to align our 3 dots or peg holes to this new vector. And using our line tool, 151 copies, and we'll offset that. Now this doesn't look bad from where we're starting right now. Jamie, we miss you guys very much too, and hopefully we can get together soon. We never see you guys frequently enough. Now that we kind of see where we're at, I want to scoot these holes in a little bit closer, and we also have room to do that because these holes aren't too close together. If you end up with the holes too close together, wall thickness goes down, and you can end up breaking things. And you never want a customer that's upset with your final product. So we'll just hit F on the keyboard and Control Z to get rid of those. Go ahead and delete this inner vector because we know where that was. And we're going to now offset this 0.32. Arbitrary number, it sounds like it'll look good to me. Again, selecting the peg holes and where we want them to align to, and we will copy those all the way around. I think that looks great right there. This has set us to where we now have all of our holes around. We have adequate wall thickness between the holes, and they go all the way around. We need to pick up a point that we're going to decide what the beginning of this is. Or do we want the beginning to be top, bottom, left, right? I think for this, we're going to start at the bottom as our starting holes. Now, the reason we did 151 copies is we're going to delete some of these. One of the things that we need to watch out for on this is, and you need to make sure that you do, is if you do not group these 3 peg holes that we used as our template to align to the circle, then they will post up when you copy them around as individual vectors. Josh, drink again. And then you have to go through and group each individual one. Because we grouped them here and we copied groups around, we're able to go through and delete. We'll go ahead and delete this one so that we know where our starting point is. And we're going to have a set of 2 starting holes. That set of 2 starting holes is going to be where we lead off from. You don't really need more than 2 starting holes because you use 2 pegs when counting score and cribbage. So we'll click and we'll delete 1. Now scoring goes in groups of 5 on this. So we count across 1, 2, 3, 4, 5, and hit delete. Now we continue counting groups of 5 all the way around until we have our correct number of groups of 5. Now, while I count, I will try to talk, and I will probably mess that up. I'm not that talented at counting and talking at the same time. So if you guys see me screw up, just let me know, and I can go back and fix that. Yes, Jamie, this is the most fun part of building a cribbage board. But the great thing is, once you have the file built, as long as you remember to save it, it's not too bad to make another one later. I suppose I shouldn't scrub the microphone with my drink. Yeah, Josh, so that brings up a great point. If you were to copy and paste the 5-hole space, what happens is because they are laid out in a grid shape around here, um, you end up with chunks. And let me get done with this, and we'll actually go through. That's a fantastic point. We'll go through and talk about why that doesn't work well. At least for not for what I want to do on this board. Now it is feasible, and you can do it, but what it ends up being is not along the race track per se. They kind of turn very blocky. Now what you can see we've ended up with here is a separate group of 3. And what this separate group of 3 is a is where we're going to put the winner's peg, the winner's hole. So we'll go ahead and we're going to delete this one and either one of those. So in this instance, we're going to delete this and select our last group of 3. We are going to ungroup these objects onto our groups layer and select only the outer and inner. Let's go ahead and count. We need 24 groups of 5. All right, so that is correct on there. And we have our 24 groups of 5, 2 starter holes, and 1 finish hole. Josh asks, how about a quarter copy and flip? So I do see what you're saying there. It's a good question. I've actually never thought about doing it that way. Um, it may take about the same amount of time because you'll have to take and create your circle and know how many circles that you have to copy along that 1/4. Trim that circle into the correct shape. Do a little bit more. I've found that just maybe the way my brain works on this is that this is what works the fastest for me. I can count to 5 usually fairly well and hit delete about 30 times faster than I can figure out the other ways. Now, once you've built the board, any variations to this can come in. Now, what we're going to do is we're going to go ahead and hit Control A and then hold Shift and unselect the lines that are not part of the peg holes. And go up to the top, and we're going to add a new layer. And we're going to name this layer peg holes. And I like to use separate colors for these new layers. And then just click off of that. Oh, that was dumb. Shift to deselect. Now we're going to right click and move to layer peg holes. Now when we select off of our work area, you can see all the peg holes are orange, and that lets us know what the vectors that we need to use are and what we're not going to use. Next, we're going to add a skunk line to it. We're not going to do a double skunk, we'll just do a single skunk line, and that is when you win by at least 30 points. So we'll count back 5, 10, 15, 20, 25, 30. So that's 30 points back. And right here, just before the 3 o'clock position, we're going to throw a line in as our skunk line. Now to do that, we're going to use the Draw Polyline tool, and we're just going to zoom in right here. And eyeballing it, we're going to draw this line from here to here. Looks like it's in the middle of it. Just go ahead and click to deselect the draw tool and kind of just eyeball where we want the skunk line. Now you can put an S by it, you can leave it just as a line. Most often people will understand that's the skunk line for this. And that pretty much completes our racetrack that we need. Now the next thing we're going to do is we need a circle that is just inside where we're going to have our racetrack. And that helps just keep things in order. Selecting the Draw Circle tool, we'll go and we'll hover over the center of the project so that we know as we drag out, oh, come on, just a little bit more. Oh, there's good. That's 8 inches. She said that's good. Now, we are still on our peg holes layer. We're going to make a new layer, and we're going to call this text circle. And again, select that and move to layer text circle. That gives us our green circle. Now we're going to get into the tricky part on this, where we need to figure out what the size of our cribbage peg pocket is and the size of our deck of cards. Having previously measured this, I know that the pocket hole for the deck of cards needs to be 2.6 by 3.6 inches. So we'll go here, and we're going to use a radius internal. And for the radius of this, we're going to go 0.125 inches. The reason for this is we're going to use a 1/4 inch end mill to cut this pocket, and that gives us a radius of 1/8 of an inch. That will create nice, perfect corners for that pocket. And we don't know what size we want it to be, or we do. We'll just draw it. I guess we could have typed it in there too, but we'll use our transform tool and go to 2.6 by 3.6 inches. The standard deck of cards is 2.5 by 3.5, but you know, as the cards get played with and they get a little bit worn, you want some room for the box of cards to fit into there. And we're going to hold a total of 9 pegs in this, 2 for each player plus a spare, or if we decide to add a scoring track to this, we will have adequate storage. And we're actually just going to use a circle for our peg storage, and that looks like a good size for peg storage. No rhyme or reason to the size, other than we're making it what looks good. Now we want to make sure the center of our circle and the center of our rectangle are aligned, so we'll align both of those to each other, and they are aligned. Now we are going to shift and click to select, and we're going to group those objects, and we're going to center those to the material. Now that those are centered to the material, we're going to draw another circle around this. The purpose of this circle is this is where we're gonna carve out a recess about 2/10 deep, and this is where the lid or center section that covers it is going to be slightly recessed in here. And with that recess, it keeps it centered, but it's also going to allow us to maybe flip it over so that you have a place to put the card on the flop. The gap between this outer circle and this circle can be used for any personalized text. You could break it up into quarters for scoring, and we can figure out what we want to do with that later. This area inside here around the peg pocket and card pocket will can also be used for any miscellaneous inscriptions, personalizations that you might want to use on your board. At this point, we're ready to go to our toolpathing and figure out how this looks. We're going to start with the outside of this. So we need to ungroup these objects. I always go back to groups, and here we're going to use our profile toolpath to cut this out. Thickness, again, we're going to enter equals Z, so that if we do change the thickness of our material in the future, whether you're using 1 inch thick or ½ inch thick, it doesn't matter. Oh, sorry, that's material setup, 0.75 again. That's what we said we're going to use. Now, this is going to be equal to Z in our cutting depth, and the tool we're going to use to cut this out, I updated my tool database today, so we're up to date now. We're actually going to use just a 1/4 inch upcut end mill to cut this out. It works well for the size of the rope border. So Josh asks, how would you remove the lid with the recess? Now the lid's not going to sit flush with the recess. It's going to stand proud of it, so you can grab the edge and pick it up. It'll stand proud by about ½ inch, maybe a little bit more than that. So there'll be plenty of room to grab it and pull it off. Here we have our outside cutout, and we're going to keep this with our naming convention. Profile 250 EM for 1/4 inch end mill. Right now we're not going to add tabs to the toolpath because we want to be able to preview it pretty well. So we'll calculate that, and if we preview our visible toolpaths at this point, you can see that it cuts it out and it keeps that ropey shape along the outside of the piece that we're cutting out. And I'm going to split screen this so that we can see both parts that we're working on. The next thing that we need to look at is our model height here, so that we can properly set this up. Now when we look at our rope border, now clicking back on the left to the modeling modeling tab, we can see that our shape height is 0.2338, and that our base height is 0 inches. Now that's not going to be really conducive to what we want. And you can see that over here in your material setup. The gap below the model is 0.5162, and the gap above the model, oh, I should not be moving that. This is where it sits in the model. So we're going to leave this where it is, and we're going to go back and look at that. So close that, and we're going to come over here. The tool that we're going to be using to rough this, or to do this, is we actually don't need a too much of a roughing toolpath, but we can throw one on there. We'll use the same 1/4 inch end mill that we're using for a lot of the other work on this, and we'll just leave it named 3D roughing 1. We can change this to 250 EM so that we know what we're done. All right, that said, oh, I didn't read that message. It said, check the pass depth for a tool does not exceed the depth of model being machined. The tool actually fits. Okay, so we don't need a roughing toolpath at all on this. Josh asks, I was thinking about a hole under the cards, centered about 3/4 inches. So the way I understand that, Josh, is you'd poke your finger through the bottom to push the top off of it using the deck of cards, or if the cards aren't in there, it would kind of pop up. It's an interesting thought, and we could build something like that into this model pretty easily if that's something you're interested in seeing how it plays out. For the finishing toolpath on this, we're going to use a taper ball nose, and my tools are named under the Amana tool number. We're going to use the 46282, and that is a 1/4 inch shank, tip radius of 1/32 inch, tip diameter of 1/16 inch. Gives a really fantastic finish, and we're going to, the default tool settings on this, I run it at setting speed 1 on the DeWalt router at a rate of 100 inches per minute. and default step over of 10%. It gives good, but you don't want to change any settings particular for your job in here because it saves it. You'll use the edit tab right here if you want to change it particular for this job. We're going to just do an offset cut and calculate this toolpath. And we're going to preview all toolpaths real quick so you can get an idea of where we're going with this. Now, if we look right here, we can see that we have this nice rope boundary on this. But if we zoom in and hold Control while clicking and dragging, that gives you your ability to move the model. Now, when we look in right here, you can see that there's this step from where the model was smoothed out and the 3D finishing pass went, and to right here where that gives that step up. Now, to give it a really nice finish, we want to clear out this entire center area so that it's smooth across there. And the question is, how deep do you go on this? Clicking the Z preview button, it positions it perfectly flat. And as we scroll in on this, if you look down here in this area of the screen, what you'll see is your Z. Now, because our material setup on this is based off of material surface, it shows 0. And when we go down here, we're looking for our maximum negative number. So 130, 145, I saw 145.6. So we're going to go 0.15 below this and see how that looks. So we'll select this inner vector and go to our pocket toolpath. Now we're going to clear using this. And to reduce the time, tool changes are relatively quick and the time savings is somewhat worth it. We're going to select our end mill that we're going to do this with. We're going to use a that's here. We're going to use a 1/8 inch 3 flute end mill. Now this is a Kodiak tool. I haven't really programmed too much in here particular to it. However, I have all the tool settings correct of how we're going to run that. So we're going to select that and we're going to use a larger area clearance tool. And for this, since we're moving a lot of material and it's really big, we're going to use a 3/4 inch end mill. And the reason that we want to do that is we're moving a lot of material on this. Two passes, all right. And we want to ramp plunge moves. And we're going to ramp these plunge moves a distance of 2 inches. Not particularly for the 1/8 inch end mill, but because the 3/4 inch end mill that we'll be using is actually just a 2 flute regular end mill or router bit, and you can't plunge on those. It's not a spiral bit. So 1/4 inch shank, 3/4 inch cutter diameter, you've got to ramp it. So we're going to call this Big Pocket and I did not set our height. There we go. We need to go 0.15 on that. So we'll calculate this and we will preview our visible toolpath. Now, to get a better idea of where we're at, we'll go ahead and reset preview, and this throws it through pretty quickly. Clears it out, and then it cleans up those edges. Now, when we go to zoom in and see what this looks like, we can see that we have a really good edge right here, and it's left us with a level playing field that we can start the rest of this on. What we need to remember on that is when we go to make all these peg holes, we need to have a starting height on it. This is a reason why I like using the layers on this. We forgot to select all of these peg holes as a single grouped object, so we would have to go around and click each of these every time. So what we can do is turn the little light bulb icon here to turn those layers off. Now when we click on our workspace and you hit Control A on the keyboard, it selects all those vectors. Now you can group all the vectors, which we'll do by right clicking, select group all vectors, or you can just go to your toolpath and select all the ones that you have highlighted. Now, one thing to note is we've got this vector here that's not going to work. So we're going to ungroup these objects back onto groups layer, and we're going to hit shift and deselect the skunk line and regroup those objects. We don't want the skunk line messing up our toolpathing. So now we'll go ahead and click this, and we're going to go over here to our drilling toolpath. For our drilling toolpath, we're going to make, we know that our start depth is 0.15. We are zeroed off the material surface, and we're going to make those from start, we're going to go down 0.4 inches. So start depth 0.15 and cut depth of 0.4. You probably don't need to go that deep, but particular pegs, the taper on the pegs, that can affect. We want to select our correct drill. Now, if you have a 1/8 inch collet for your router, you can just use a regular 1/8 inch drill bit as long as you've got a short one. You can use a 1/8 inch upcut end mill. What I use is a, oh, where is it in my tools? I don't see it in here. It's a Mana, Kodiak, a Mana 3-flute upcut, downcut. Oh, I have it in here as a V-bit. So these are just some cheap carbide chip breakers that have a 135 degree drill point on them. I used them for drilling some carbon fiber or cutting carbon fiber, fiberglass composite, whatnot. Got them for $10 for a pack of 10 or something like that. But they also make great holes, and they kind of burnish the inside of the hole, which adds a nice contrast to it, in my opinion. But because they have the split point, they can drill, they ream out the hole, it works perfectly. The machine is just going to do what you tell it to do, so if you can figure out how to manipulate your tool selection into your tool pathing, that can do great things. We can drop this down. I used to have my tools selected to 25,000 RPM because I ran them with the router on 6. That is completely unnecessary when you start looking at chip load calculators. Run it on 1, maybe 2, depending on what you're doing. It doesn't need to go any faster than that for the speed that most hobby grade CNC routers will travel. And that gets into a completely separate topic with designing or selecting and calculating correct feed rates and chip load characteristics. So we've got our tool calculated. We're going to use peck drilling, and we're going to retract above the height of the previous pass by 0.1 inches. And that's just to help clear some of the swarf out of the hole. And we don't need to dwell at the bottom. Dwell time is how long it's just going to sit there before you retract the drill bit. We are not projecting this onto a tool path, and I don't feel like it's important at this point to select a different name for the tool path. It's the only one. We'll go ahead and preview our visible tool path, and you can see that all of our holes are now in here. We'll go ahead and relight all of our layers that we have. The next thing that we're going to do is select our skunk line, and we're going to V-carve this. Again, remembering that our start depth is 0.15, and we're going to use a 60 degree V-bit. Sorry, selected the wrong thing. We're using a profile toolpath, starting depth of 0.15, and we want to make this line 35 thousandths deep using a 60 degree V-bit. That's a 60 degree half-inch V-bit. We're going to do it on the selected vector. It should be one pass. Don't need to ramp it, don't need to add tabs or a separate last pass. And we're going to call this skunk line 60V. and we'll calculate that. With this being calculated, we'll preview our visible toolpath, and we can rotate this around, make sure that we're happy with how our skunk line looks. Now, if we wanted to make this stand out for how it'll look finished, with this highlighted blue, we can go to toolpath color and select a toolpath color, because we might paint that line black when we're finishing this board. Moving on to the next portion, we'll go ahead and select this, and this is going to be our smaller pocket. Again, going to our pocketing toolpath, and our start depth is going to be 0.15. If we don't select that, it's going to machine air for the first bit, and we want to machine this 0.2 deep. And on this, we don't need to use a larger area clearance tool because it's just a circle. We don't have any detail around the edge that we need to do. So on this, we'll use our 3/4 inch end mill again. We'll hit select on that. It'll take 2 passes. We'll offset it kind of and we still want to make sure that we have ramped tool paths, and we'll calculate this out. And when we preview our visible tool paths, we can see that the difference in height, when we select our Z here, it is minus 0.15, and this is minus 0.35. So we have in fact machined down another 0.2 of an inch to create this pocket. Next, we're going to create our peg and card storage pockets on this. I'm actually going to not ungroup these. Let me check my phone real quick. And we are going to use our pocket toolpath. Again, we're going to use a clearance tool on this, and we're going to change our finish tool back to a, let me think what our most efficient. We want to minimize tool changes as we go through this. Really, not minimizing tool changes just sets you up for potential variances, and it takes time. So if you can get everything done with fewer tools, it does set you up for success on this. And so what we're going to do is we're actually going to use the clearance tool, and our finish tool on this is going to be our 1/4 inch down cut. We'll select that. We have that. We have plunge moves, and we're going to call this pegs and cards 250. Well, pegs and cards. It's going to create two tool paths, one for the clearance on it and one for the finish on it. And we'll preview our visible tool paths. Well, look at that. We didn't set it up right. So our initial starting height is going to be 0.35 as we looked at it in our 3D model. And we need to make those a certain depth. Now, we can't go deeper than 0.4 on this. That will put us through the material because it's 3/4 of an inch thick. And we know that a deck of cards is approximately 3/4 of an inch in diameter. So what we're going to do with this is we're going to make this pocket 0.3 deep. That's going to put us at 0.65, which leaves us 1/10 of an inch in the area of the bottom of those, which is a fairly good amount of material still for the area. You wouldn't want to go very big, but 1/10 of an inch using good hardwood is sufficient. And we'll calculate that and preview our visible tool paths again. And that gives us our peg pocket and our cribbage peg, our peg pocket and our card pocket. And you can see when we scale to our Z preview, minus 6.65, which is 1/10 of an inch of material remaining at the bottom of that. And that pretty much completes what you do for the bottom of it. One thing I do see that is kind of a visual thing that I think would look better, and we'll try it out, is we're going to throw a profile toolpath onto this vector just to give us a a look at how it looks. So start depth 0.15, 60 degree V bit, and we're going to call this inner trim ring 60V. And it's going to cut to the same depth as our skunk line. And we'll preview our toolpath and make that one black as well. So that really makes it look a bit better. It gives us some visual separation between the racetrack around the outside and the decorative inner portion. Now we want to make sure that we save this. So we're going to work on my round cribbage board bottom. And we're going to save that. Up here, we're going to open up another fresh copy of VCarve desktop, or whichever Vectric software you're using, and we're going to create a new file. For the purpose of this, we're just going to leave the job type, width, height, and material thickness exactly the same as we had it. It can change later. What we do know that we need is this is the circle that we used to step down for our lid. So we're going to go ahead and hit Control-C to copy that, and then Alt-Tab back over to our other window. And then Control-V, and it pastes that same exact circle that we were working with right in the middle. Now, if we were to cut on the outside of this, it would not fit. You have to give some amount of clearance gap between the two pieces. How much clearance gap do you want? That's kind of a personal opinion, but I'm going to say that if you give it 25 thousandths clearance, it's going to give a nice fit, and it's not going to make it wonky. Jamie asks, can we make it a dome lid? Yes, we can make it a dome lid. So what we're going to do with that is, Jamie, do you want anything on this domed lid? We'll start with that. We can put another 3D clip art on there. We can put just words. We can do words on a domed surface. Choice is kind of yours on that one. And while he's thinking about that and maybe writing a reply, I'm gonna take a sip of water here, and I've been talking for quite a while. All right, so we'll do my name. We know that we need to offset this 25 thousandths towards the inside. What we need to do initially, though, is we're moving this inwards. And if we say that we're going to move it 25 thousandths inward, we actually need to offset it half that distance. And I'll show you why. Right now, if we go to our transform objects and the set selected object size, we'll see this is 7 inches. Now, if we offset this inwards, a distance of 0.025 or 25 thousandths, and we offset that, and we select this new line, we can see that it's 0.695. So that offset from outside to inside is on each side of the vector. So what the offset needs to be, because this is now 50 thousandths smaller, we actually need to go half of the distance that we want that whole diameter smaller. So we'll close that and hit Control-Z to get rid of that. And we're going to go 0.0125 and offset that. Now, what we can do is delete the original. Not going to really worry about that too much at this point. Now, all right, this is where we're going to change things up. We want a domed lid with submarine insignia and business name on the outside, so fish. And we need a dish on the inside of it, or a recess, so that it will fit over the cards and the pegs. Because our material was only 3/4 of an inch thick to start. We know the deck of cards is 0.75 inches thick. Our pocket is only 0.3 deep. So we need a pocket on the inside of the lid. So what we're going to do is we're going to go to a double-sided machining process on this. And one of the best things you can do for a double-sided machining process is to add holes to your workpiece that align with a spoil board so that you have registration holes to align to and you're not working off of any wonky measurements. So we're going to set our Z0 off the material surface, and we're going to keep it in the middle. And we're going to flip it from bottom to top. That'll work just fine. So up here you can see that now we have a toggle top bottom side part. We're going to work on the top of it first, but we need to do some things to this. We are going to delete this outer circle, and we need to Alt-Tab back to our other project, and we need to copy our peg hole and cribbage hole, or peg pocket and card pocket, back into here so that they all line up. It would be terrible to make this and things don't line up. And we know those grouped objects were aligned to the center of the material, so we can just click on that again and make sure it all lines up. Now we need to decide if top means top and bottom, inside, outside. We're just going to go with really simple convention. On the toggle top bottom, it's going to be what we're looking at. So if you would say the lid's upside down, you're looking at the bottom of it. What we need to do for that, because these are going to be on the inside or bottom of this, is we're going to select them, right click, and go to move to other side. And you can see that they're ghosted out. That way we know where they are. We know this is going to be our outside diameter of it, and we want to add some cool things to this. The first thing we're going to do is we're going to go to our clip art, and we're going to go to domes and dishes. It depends on how bubbly I guess you want this to be. You have a 30, 45, 60, and 90 degree. We're going to give this a nice gentle domey shape on here, so we're going to drop this right in the middle. And going back to our drawing tab, we're going to select align to material, throw that in the middle, and now we need to change the size of this. If we click back on this outside diameter, we're at 6.975. So we know that if we select this, we can go 6.975, apply to it, and it is now exactly the same size as the outside cutout of this. Now, if you want it to be a little bit bigger so that it kind of gets cut out and it's really smooth edge, which is a great idea, you can actually just make this whatever arbitrary size. We'll actually just make it 7.25 inches. Whoa, 70 is a little large. And when we go to our toolpathing, that'll make sense because we're going to machine that to to the selected vectors. The next thing that we have on our top here is we want to add a set of the submarine warfare insignia. So I need to select these. I brought these in earlier, and we're going to use style B on this one. We're going to drop these right here in the middle of it and go back to our modeling tab and kind of 3D view this so we can see where that is. Now that looks absolutely terrible right now because we have this dome dish and then it drops down hard in the middle. You can see that the add subtract is not where we want it. If we go here, it's no good. We go here, that's what we're talking about. Nope. There we go. So it's domed up, but then that cuts back down on the inside of it. I think that looks fantastic personally. So we'll go ahead and close that. And when we look at our dome dish, we can see that that's 0.48 tall. And that shouldn't be too much of an issue. We can always change this, manipulate it a little bit later on. But the concern that we have, clicking back over to our 2D view, is we need to make sure that is perfectly centered. And we'll align that to center of the material. Kathy says 151. Yes, it does a lot of things in our lives. So now we have our dome dish and our fish on here. Let's go ahead and add a name. So for this, we're going to draw a circle. We'll pop right here to the center and drag this out to about here. Again, selecting our circles and closing that. Kathy, so 151 circles is because we're going to delete every other so that it gives us groups of 5. And you can see what we end up with is over here we have 24 groups of 5 that gives us our 120, and then that one last hole gives you 121 points for the win. Going back over to our lid project, and thank you Jamie and Josh for helping out with the explanation on there. We want to go into our node edit tool to split this into an upper half and a lower half of the circle. Using the node edit tool that we covered last night, we're going to hit N on the keyboard to node edit and then hover over each of these, and we're going to hit C to cut the vector. Josh, drink again, and hit C again on the opposite side. Hitting F to return to our home screen or fit to screen, and then hit escape. You can see that we have a lower half and an upper half now. Along the upper half, we're going to write we'll make this long text, and we're going to throw another text box right here at the bottom. We'll put my name along the bottom, business along the top, and we'll go with Times New Roman font for this. So you can see that this is much longer than the length of that curve. That's fine. So click the text and then shift click to select the vector. We're going to go to the vector alignment or the text on a curve tool. It says, hey, your text is too long to fit on the curve. That's fine. We're going to scale the text to fit to the curve 100%. Looks a little bit long, and we can see that it's going to stick over our 3D model that we put in the middle right here. So we want to keep away from that an appropriate distance. Text alignment, we'll throw it to the middle, and you can scale the text to fit the curve. About there gives it a fair margin, and we're going to align it on the curve. Above the curve works, and then we're going to do the same thing again. Just click off of the selected, click on the bottom text that you want, and then shift click and put it on the bottom. Again, we'll throw it to the middle and on the curve. Because this text is much larger than this, it looks okay from an outside standpoint of where the outer diameter of the text is. Now, if your text were backwards on there, you would select the text on other side and it flips it around if you wanted to keep it in a circular pattern rather than a top-bottom. But because the graphic in the center is directional, we're going to keep all the words upright on this. So we'll go ahead and hit close and then click off our work area. And that completes what we're going to do for the top side of the lid. Now, when we go to the bottom side, we've got our pockets for the cards and the pegs. The pegs don't really need a deeper pocket on here, so what we're going to do, we're going to keep it so that if we lose our alignment position, we can regroup the objects and align them back to the center of the workpiece. But all we need to do is cut a pocket for the cards. Now, let's go over here and we'll start with working on this. Now, to make sure that we've got our correct depth here, we know that this hole is 0.3 deep, and that hole sticks up. So we've got 0.45 of the card that still needs to stick up above there. And that gives a good amount that we can grab with our fingers. But that means that the hole in the top portion needs to be 0.45. And we'll go ahead and say that we're going to make this 0.45 deep. Pocket toolpath, material setup, and everything looks good there. So we're going to go 0.45 on this. We'll use our 1/4 inch down cut. We're going to minimize tool changes, so we're not going to use larger area clearance tool on this. And let me get rid of caps lock. Again, we'll just call that card pocket 250 EM and calculate that. And if we preview that visible toolpath, that's what it looks like. Flipping back over to the top side, and we'll hit this button right here at the top to arrange views vertically so we can kind of just see what we're working with and we don't have to toggle back and forth as much. The first thing that we want to do is we want to go ahead and we're going to do a 3D roughing toolpath on this, and we're going to do it to the selected vector. So shift click, so Jamie asks, do you only need 1/10 for the top if the bottom is 0.65? So that's 0.65 from the material surface. That doesn't take into account the 0.15 that we came down for that initial pocket that we cut to make the rope border look really good, and then the next 2/10 that we took out for the area where the lid is going to sit. So that pocket, where if you were to like put the deck of cards in that hole and scribe around it, it's only 0.3 inches into that hole. And we're probably gonna talk about this here in just a minute, because I have a feeling that this is going to result in a failure how we're doing it, but it's a great learning example. So we're gonna machine this. This is going to be our roughing toolpath. We're going to use a 1/4 inch end mill because it's already in the machine. It might take a little bit longer, but it minimizes the tool change again. So we are going to raster along the Y on this, and stick with our conventional naming for this. And we can preview our visible toolpath here that our 1/4 inch end mill has hogged out that much waste from it. Now we need to go into our finishing toolpath. And our finishing toolpath on this, we're going to use we're going to use the 46282 again. It might take a little bit longer, but it's going to minimize the tool change, and you can just let the machine run while you go have a beer. This has been a great go-to bit for a lot of projects, and we're going to let that run. And that's just going to take care of the whole thing. So what did we do here? We need to go finishing toolpath. We're going to select that and 46282 and calculate our toolpath. Now this takes a little bit longer to calculate. There's a lot of lines that it's got to do for the dish and for the dolphins in the middle. Now we can preview our visible toolpaths, and that is the failure that was anticipated right there, is because our dome shape comes down, the corner of our pocket that we cut on the bottom side pokes through. And aren't we glad that the software has the ability to show us that? So if we go into here, we have our model position in the material. It's already at the top. That's the first thing to check. And we need to decide how we're going to combat this from blowing through the material. Now we have a couple options on this because we're already at the top of the material when we machine this. And that's seen here that our model position in the material is all the way at the top of the material. So we can't make it any thicker. Now we have options of using a thicker piece of wood to accomplish the task, or we can manipulate the 3D model that we have. So when we come over here to our modeling tab, we can see our shape height is 0.48. Now that's just under 7 inches and it's a ½ inch thick. So let's go down to 0.25, and we can see here in our 3D model how that flattened everything out. Josh, you wouldn't believe how many things are hidden with wood glue and sawdust. The other option that we have is to kind of go back to the base and redo our peg pocket and put the cards directly in the middle and make a rounded tray that kind of lets the pegs fall elsewhere. And that is a viable option if we want to go that way. So right now what I've done is I've just reduced the shape height to 0.25 inches, and we'll close that. And when we look back at our where we are in the material, we're going to leave a little bit, just a tiny gap, 30 thousandths above. And yes, we want to recalculate all of our tool paths. Now when we preview all sides again, need to reset preview. Preview all sides, top's done, bottom, and look at that. Now, how do we know if we are going to blow through on those corners? Well, they were the outermost corners, and let's check our material thickness. So control and mouse over and look at here, and that shows us it's minus 0.3. And it looks like we've got about 20 thousandths or so, 16, 15 thousandths, 14, 13, 12. Looks like it'll be pretty good from a material thickness standpoint. So not too much to worry about on that. So on the bottom side, we have a peg or a card hole. And on the top, we have our dolphins carved in. The last thing that we need to do is we need to VCarve our text and then cut it out. So we'll select our text and we're going to VCarve this. For this, we're going to select a you go to my Amana wood V-bit quarter shank 45 771K. This is a 30-degree 5,000th point engraving bit. Fantastic bit to get. Now where it comes in is we're not going to set a flat depth. We're not worried about it. Not going to use clearance tools. But what we need to make sure that we click is project toolpath onto 3D model. And we're just going to call this words 30V. And now when we preview that visible toolpath and we make our toolpath black, zoom in here, you can see that it actually applied that text to the curved surface so that it stays with that. The last thing we need to do is cut this out, and we know that this is our line to cut it out. So we're going to use our toolpath here. We're going to make our depth equal to Z. We're going to make sure that we use the right tool. So we're going to use a 1/4 inch down cut end mill. We're going to add tab. Well, we're not going to add tabs right now. We want to make sure we're going to machine this on the outside of it. And we're going to call this cutout 250 EM. And we're going to calculate that. And when we preview our visible toolpaths, delete the waste, you can see that we now have a lid with the remaining depth for the card pocket on there. And that makes our lid. Now if we wanted to add another attribute to this, we could add 2, 3, 4, however many you choose, magnets to the back of this and on the inside of our other model, which we would be able to then attach that with magnets and then pick it up at the end. Now with this dome dish setup here, we can see that it's pretty thick and chunky, and this is something you definitely want to make a bit of a preview on to make sure that you can grab it and remove it. Like Josh said earlier, maybe putting a hole that's big enough for a finger to go through the back side of it and pop the lid off in case you can't grab that circle. That would be a good idea to do, as long as you make sure that the lid's not going to rotate or have a gap to where the pegs are going to fall out. So that about finishes it. Is there anything else? Does anybody have any comments or questions on what we've covered, tools we've used, tool pathing? Jamie asks, how hard is it to cut this two-sided? Do you have to cut the bottom, flip it to the exact same spot? Yes, you do. So with cutting two-sided operations, I find that it's best to make a separate toolpath. And I can cover that in another video where I actually go out to the shop. It won't be a live stream, where we set a spoil board with dowels in it, and we run the toolpath to drill the holes in our material. That way our material aligns to our spoil board with these dowels, and it does not move. You know that the spoil board is centered and your workpiece is centered. Two-side toolpathing sounds like it's a little bit daunting, but it's really not too bad once you've done it once or twice. And getting those holes so that it lines up is kind of a foolproof way to make sure that you don't have problems with workpiece misalignment. And if there's any last questions coming in, I'm actually going to go and throw the holes in that Another idea would be to recess a section a little deeper so you can push the lid down. Not a bad idea there either. We kind of covered that using the fluting toolpath last night. You can make it slanted across there. You could even just make it a cutout. And realistically, if you wanted to make your peg pocket along one edge, so that your pegs sit along that edge where you push the lid down and your cards sit perfectly in the middle, that is another option for this. And like I said at the beginning, this is really just taking those ideas that are on the screen, pictures we saw, and making it your own. We're not trying to copy or duplicate anybody's work. That would be way too easy. So add your own style, add your own flair, and make it what you want it to be. All I want to show you is how to use some of the tools that are in the Vectric software and how I accomplish the tasks. There might be other ways, there might be faster ways, but making it look really good because it's your design is what's so important. Jamie says, this would be great to come over and show me at my house. Well, Jamie, you've got the tutorial on how to build the file, some ideas on what you want to do, and I know you've got great lumber to do this, and it's something we can certainly talk about. We've now been talking for an hour and 15 minutes, and I think this video is about wrapped up now. I need to go in and save this other file so that we don't lose that, and we'll hit File, Save As, and move this over, And we'll call this top, and we'll save that. And I will put these up on the Facebook CNC for Beginners group, and this video has also been recording the whole time. It will be uploaded to YouTube, and there will be a link posted for that, so that anybody that wants to see this later, you can do the live stream, watch the live stream over again, or watch it on YouTube. So I really appreciate all you guys that have had comments, listen to me drone on for an hour plus, and for my wife for being patient with me while I use her computer, her room, her setup, her headphones, all of that. Thank you guys, and until next time, keep your fingers out of the table saw.